Hi, so for this video, I'll be discussing about linear inequalities in one variable. The focus will be on translating sentences to mathematical sentences, followed by compound inequality, just the introduction, and lastly, we will have representing linear inequalities on a number line. Okay, let's define inequality. So inequality is a mathematical sentence expressing the relationships between numbers with symbols less than equal to, greater than equal to, or not equal to. A standard form of linear inequalities in one variable can be written in different forms. You can have ax plus b is less than c, ax plus b is greater than c, ax plus b is less than equal to c, ax plus b is greater than or equal to c, or ax plus b is not equal to c. Remember that the value of your a, b, and c can be any real numbers, but a cannot be equal to 0. So why a cannot be equal to 0? Remember that if your a is equal to 0, if you substitute it then to your inequality, it will cancel out your x. So once the x is cancelled, then you don't have a linear inequality anymore. Let's have some examples. So consider which of the following is a linear inequality in one variable. Let's have number 1. So x is less than y minus 3. So is this a linear inequality in one variable? The answer is no. So this is not a linear inequality in one variable. The reason is that you use two variables here. You have an x and a y. Okay, next for number 2, you have 4c is greater than 1. So is this a linear inequality in one variable? Of course, yes. Okay, you have one variable, as you can see here, and you do use an inequality symbol, which is greater than. Let's have number 3. 2k minus 5 is equal to 3. So is this a linear inequality in one variable? This is not. Okay, and why so? That is because although we have one variable here, which is k, so we're okay with that, but it doesn't satisfy the condition that you need to use an inequality symbol. Instead, you have an equal sign here. This is equality symbol. So this is not linear inequality in one variable. Let's have the fourth one. R minus 7 is not equal to 2 plus 3r. Okay, so the answer here is it's a yes. You only have one variable here, which is r, and you do use an inequality symbol, which is not equal to. So this one is a correct symbol, so it's a yes. Last one, you have 10 minus 9m. This is very obvious that this is not a linear inequality in one variable. So you have one variable, but you don't have inequality symbol here. So this is not linear inequality in one variable. Okay, now let's have translating mathematical statements to linear inequalities in one variable. So I have here some of the terms or words we usually use to denote specific inequality symbol. Again, this is not limited to these words. There are more. Okay, so for less than, you can have is less than and is under. For greater than, you can have the words is greater than, is more than, is higher than. For less than equal to, of course, is less than or equal to, is not more than, is at most. For greater than equal to, you can have is greater than or equal to, is not less than, is at least. Okay, And then for not equal to, you can have is not equal to, is anything except, or cannot be. Okay. Now, let us try to write some mathematical statements to linear inequalities. Okay, let us have this example. But before we start, take note that for the next three examples, we'll be using x to represent the number. So let us write, so let x be the number. Okay, let's start. The first one, the difference between a number and 8. So when we have the word difference, it means that the operation that we are going to use will be subtraction, which is minus. Between a number, so we have already represent number as x, and 8. So let us write that one. So that would be x minus 8. Okay, let's continue. Divided by 3. So since this is division, we can write it in a fractional form. So we can have divided by 3 is not more than 2. So our inequality term here is not more than. So if you think about it, so maybe you haven't memorized the table that I have shown you a while ago. When we say it's not more than 2, so it means that the highest possible number that we are looking for is 2. So thinking about it, the symbol that we are looking for, the inequality symbol that we are looking for, is the symbol less than or equal to. Okay, and then let's write 2 here. That's it. Okay, let's have the second example. So 4 times the sum of a number and 6 is greater than 1. So let's start with 4 times. So 4 times, so you'll have multiplication here. 4 times the sum of a number and 6. So we represent the number as x and 6. So sum of a number and 6, so that would be x plus 6. And then 4 times x plus 6. So we can write that this way. 4 times x plus 6 is greater than 1. So greater than 1. So this is simpler than the first example. Let's have the last one. Half a number subtracted from 8 is not equal to twice the same number. So half a number, so same thing, we let x be the number. So half of that, so that is x over 2. Subtracted from 8. So we do subtract it from 8. So we put 8 before x over 2 is not equal, so that one is this in symbol, to twice the same number. So 2x. Okay. So now let's have our second topic. We'll have compound inequalities. So like what I have mentioned, we will only have introduction about compound inequalities, since I'll be having a separate video where I'll show you how to solve compound inequalities. So mainly we'll have simple definition and how to write it in, from words to inequality symbols. So let's have the definition. A compound inequality contains two inequalities that are separated by either an and or an or. Okay, let's have some examples. So let's translate this one to compound inequality symbols. So the first one is x is greater than 2 and less than 6. So now if we use the word and, okay, so our compound inequality will look like this. So we use a variable x, right? So let's put x. And then we have two numbers here, 2 and 6. So there's two numbers. So you can write it on opposite sides of x, 2 and 6. Now let's get back here and decide what inequality symbol we are going to use. So it says here x is greater than 2. So if you write the symbol, it should be like this, right? So x is greater than 2. Next, x is less than 6. So the symbol should be like this. Okay. Now, if we use or, like what we have on example number 2, x is less than 2 or greater than equal to 6. So we are going to write them as a separate inequality. So let us have first x is less than 2. So x is less than 2 in symbol is x, and then we have the less than symbol, and then we have 2. And then you need to put the word or, and then write the second inequality, which is that x is greater than or equal to 6. Okay, so as simple as that. Okay, so now let's have our last topic for this video. We'll have graphing linear inequality in one variable. So the inequalities can be graphed on the number line by using symbol. So first, use an open dot for less than or greater than. We'll have examples of this later. So you'll be using an open dot like that. And then second, use solid dot for less than equal to or greater than equal to, like this. Let's have some examples. So draw the number lines representing the numbers or the inequalities shown below. So the first one is x is greater than or equal to 8. So since we have greater than or equal, so it means that we'll be using a solid dot. And then next step is to get 8 and locate it on your number line. So your 8 is here. Now again, we'll be using a solid dot. So you can draw the solid dot either on the number line or on top of your number line. So I'll be drawing it. I usually draw it on top of the number line because it's easier to see it. Okay. So let's make a solid dot there. Okay. After you draw your solid dot, now it's time to draw your arrow. So since you have greater than or equal to, so it means that the arrow should go to the right direction. So let's draw the arrow like that. And that's it. Let's have another example. This time we have x is less than negative 2. Okay, so our inequality is less than. So if you have less than, we need to use an open dot. So now let's locate negative 2 on our number line. So negative 2 is here. So let's draw an open dot. Okay. Now we'll be drawing an arrow to the left because this is less than. So let's draw an arrow. And that's it. Okay, let's have more example. So this is a third one. X is not equal to 1. So we didn't have like a specific rule for not equal to. If you remember, I only mentioned about using an open dot for less than and greater than, and a solid dot for greater than or equal and less than or equal to. But we can use the same concept in graphing x is not equal to 1. So if we think about it, when we say that x is not equal to 1, we can have any values for your x except 1. So for that, what you need to do, okay, locate 1 on your number line. So here's your 1. Now we need to decide whether we should be using an open dot or a solid dot. But since 1 cannot be included to the list of values of x, we should use an open dot. So we will put an open dot on top of 1. Okay. And then now it's time to decide where to put your arrow. So again, we can have any values for x except 1. So we can have numbers greater than 1. So we can put an arrow to the right. And we can also put an arrow to the left, since we can also have values, okay, that is less than 1. Okay, so I hope you got how it works. Let's have another example. So x is less than -7, or x is greater than or equal to -3. So you have two separate inequalities here, so you can just draw them as it is. Okay, so let's do first x is less than -7. So less than, so meaning we will have an open dot at -7. So let's show the open dot. Okay, and then it's less than, so your arrow should go to the left. Okay, next, x is greater than or equal to -3. Our inequality is greater than or equal, so it should be a solid dot. So draw a solid dot on top of -3. Okay, and then an arrow. This is greater than, so your arrow should be to the right direction. Okay, so that's it for number 4. Last example, let's have this one. So x is greater than or equal to -1, but less than 4. So we have a compound inequality also, same with number 4. So if you have something like this, make a mark first for -1 and 4. So for -1, we have the symbol less than or equal to, right? So meaning it should be a solid dot. So let's put a solid dot on -1. Okay, and then for 4, we have there less than, so it should be an open dot. Let's have at 4 an open dot. Oh, sorry. Open dot. Okay, now as you can see, your x is greater than or equal to -1, so that the arrow should be to the right. Okay, and then for 4, your x is less than 4, so that's to the left. So it means that your values of x should be between -1 and 4. So you can just connect them by a segment or a line like that. Okay. Okay, let's have more examples. So, but this time we are given the graph, and then we need to identify the compound inequalities shown by this graph. So let us have the first example. So if you look at it, you can see, of course, 2 dots, which tells us that it's a compound inequality. And of course, we have two arrows also. So when you see arrows that goes to two opposite direction, like this one, it means that you need to use an or to describe the compound inequality. So let's do that. So let us write first an inequality that will describe the one on the left side. Okay, so this is above 4, and we use a solid dot. The direction of the arrow is to the left, so meaning we'll be using the symbol less than or equal to. So let's write that one. So your x is less than or equal to 4. And then, like what I have said, we'll be using an or. And then let's write another inequality for the right side. So this is x. We have an open dot, and the direction of the arrow is to the right. So our symbol is greater than, and the number is 7. So the final answer is x is less than or equal to 4, or x is greater than 7. Now for the second example, we see two dots again, both solid dots, connected by a segment. Okay, so if you have something like this is how you write your compound inequality. Write first an x, okay? And then after that, check the two numbers on top of your dots. So this is -10 and 0. Okay, now, as like what I have mentioned, the dots are solid dots. Okay, so we are using an equal to for your inequality. So look back again on your given graph. So the value of x should be greater than or equal to -10. So greater than or equal to -10, but is less than or equal to 0. So this is your final answer. So this is the last part of our lesson for this video. I hope you learned something. Goodbye.